All right, this lesson is on limits and infinite geometric series. An infinite sequence is one in which there are an infinite number of terms in the sequence, and it's usually denoted by 3 dots at the end of the sequence. That lets you know that it continues on forever. A limit is the value that the sequence approaches as n increases or approaches some value. All right, so as the number of terms increases, whatever value the sequence approaches, that's going to be the value of the limit. So the way that this is how you would express a limit, and the way that you read that is the limit of x as x approaches infinity. Or you could say the limit as x approaches infinity of x. Notice that as x approaches infinity, so does the limit. Here's just some rules for how limits behave. So if you have a limit as x approaches infinity of 1 over x, notice that as x gets bigger, the limit is just going to get smaller and smaller and smaller. It's going to get closer and closer to 0. It's never going to approach 0, but it's just going to keep getting closer and closer to 0. So 1 over the limit as x approaches infinity of 1 over any variable to a power greater than 0 is always going to be 0. And then some rules for the limits. The limit of the sum of 2 terms is the same thing as the limit of both of those, the sum of both of those limits. Same is true for subtraction. The limit as x approaches infinity of the product of 2 factors is going to be the same thing as the product of those 2 limits. And then the limit of a quotient is the same thing as the quotient of the limits. And the limit of a constant is always going to be just the constant. All right, first example. So what we want to do here is divide the numerator and the denominator by the highest power in the denominator. The highest power in the denominator is 1, so I'm going to divide the numerator and denominator by x to the first power. When I do that, I get -1 in the numerator, and then in the denominator, 1 minus 0. -1 over 1 is just -1. Another example, similar. Highest power in the denominator is 2. So I'm going to divide the numerator and denominator by x to the second power. Whenever I simplify each of those terms, -9x over x squared, that would simplify to -9 over x. And the limit as x approaches infinity or negative infinity of a constant over a variable to a power greater than 0, it's always going to be 0. So the numerator is going to be 0. X squared over x squared is just 1. And then the limit as x approaches infinity of 9 over x squared is just going to be 0. So 0 over 1 is 0. Now we have the limit of a polynomial. For polynomials, the term with the highest power will always demonstrate the behavior of the limit. So all we really need to take a look at is the limit of x to the 4th power as x approaches infinity. And the limit as x approaches infinity of x to the 4th power is just going to be infinity. You should be able to determine whether the series converges or diverges. If an infinite series has a sum or a limit, the series is said to be convergent. Otherwise, it is divergent. So if we know what the common ratio is for the geometric series, if we know what the common ratio is, we just take the absolute value of the common ratio and determine whether it's less than or greater than 1. If the absolute value of the common ratio is less than 1, it's convergent. If the absolute value of the common ratio is greater than 1, it diverges. And the sum of all the terms, an infinite series is just the sum of all the terms in an infinite sequence. And to find the sum of an infinite series, we just take the first term in the sequence and divide it by 1 minus the common ratio. All right, so first in this example, we want to determine whether these converge or diverge. So I take the second term, divide it by the first term. Whenever I divide those two, I get the common ratio, which is negative 1.6. And the absolute value of negative 1.6 is positive 1.6, which is greater than 1. So that lets us know that this diverges. It's divergent. Do the same thing for the second series. We got 3.44 divided by the preceding term, 4.3. When we divide them, we get 0.8 as our common ratio. Take the absolute value of that, and it still get 0.8. 0.8 is less than 1. Therefore, that lets us know that the series is convergent, or it converges. All right, now we want to evaluate this infinite series. It starts at 1 and goes all the way to infinity. There's an infinity above the sigma. So first thing we want to do is find out what a sub 1 is by plugging in 1 for I. And we get 2 for the first term in the sequence. And then we're going to find out what the second term is in the sequence by plugging in 2 for I. And we get negative 2/3 for the second term in the sequence. Now we can determine what the common ratio is. So we have to multiply 2 by the common ratio to get the next term. So that means the common ratio is negative 2/3 times 1/2, or negative 1/3. Now we can plug those values into the formula. So we have S equals the first term, a sub 1, which is 2, over 1 minus R, and R is negative 1/3. 1 minus 1/3, 1 minus negative 1/3 is 4/3. And then 2 divided by 4/3 is the same thing as 2 times 3/4, or 3/2. So the value of the infinite series is going to be 3 over 2. And lastly, we want to determine what the common ratio is for this infinite geometric series. We're going to use the same formula, except now we will have a value for S, and we're going to solve for R. So we plug in 0.625 for S, plug in 1 for a sub 1, multiply both sides by 1 minus R, distribute the 0.625, subtract 0.625 from both sides, and then lastly divide both sides by negative 0.625, and for R we get negative 0.6.